Hey guys, it's Chris Ellery here at Southeastern Pennsylvania, and we're going to do another video today. I had a little trouble trying to get this one together because, well, we're going to talk about cleaning the data, the SNAP data across 5 states to make it a lot easier to work with, and I had some issues. I've actually tried to make this video about 3 or 4 times now, and there was always this one little thing in a column that I didn't understand. So I had to go back through and make sure I understood what I was doing first. That's why it's taken me a few days to get this back up and running. But we're going to start today with running in the code from a video previously where we collected all the SNAP and poverty-related data from the census that we'll be using. Then we're going to go over how to drop columns that we don't need, renaming those columns that we're left with, and then we're going to use a filter to find issues within the data that are going to make, well, gave me trouble. And then finally what we should end up with is a data set that we can actually start to analyze. So altogether, I did want to make sure you guys understood how to drop unwanted columns, how to filter through data sets, and how to deal with inconsistent data, learn how to sort a data frame based on values of a specific column, and learning the difference between a string, an integer, and float types. And also, lastly, but we'll actually be doing it first, is how to install a library within an active environment. Today, we've mostly been using pandas or GeoPandas, and I've in previous videos shown you how to download libraries using Command Console. But what if you don't have a library that is on a project that you're working on and you don't want to shut down your entire environment just to get to it? Well, in that case, you can actually run a pip install command right from the Jupyter Notebook. You should have numpy already in. I think it is standard or maybe a prerequisite for pandas. But either way, just in case you don't, let's assume that you didn't and you wanted to. We will be importing numpy in just a minute, so let's go ahead and download it through here. So what you do is you enter the cell of your environment, and then it's the same thing that you would enter in with your console command, except it's going to start with an exclamation mark. Exclamation mark pip install numpy. Enter, and this should just take a second. Yep, there we go. My requirement's already installed, so I actually don't have to worry about reinstalling it now. And then the next thing that we will do is we will run import pandas as PD. Okay, let me just go ahead and copy and paste this in here. Just one second. There is one difference from how we did this before that I want to get into. Basically, we read in the data similar to how we did last time. T1 is your variable, PD, pandas.readcsv, then the file path name, and we did a skip row before. But what I want to do this time is I want to read in every single item on this list as an object or a string. And the difference between them, basically this. Type, let's say that you have a letter, A. It's a string value. Letters, non-quantifiable numbers, these are strings or objects. The difference being, if you had, let's say, a 1, you have an integer. Different type of data. These are numbers that can be quantifiable, added together, average, median, sum, all those things apply here. Now the float is the third basic type of data, and, oh, excuse me, that is for basically any number with a decimal. That is a float. So what I know is going to give me a problem later with this data is there's going to be some columns that should be integers, but they are objects. So to make everything just a little bit easier, right off the bat, I'm just going to convert everything to an object so that I can filter things out in a common way. And we'll get into the more specifics in a little bit. First things first, let's go ahead and read in our T3, because that is the table that we have. And our table, like we ended with last time, it's 5,162 rows and 567 columns. We don't want all those columns. We just want to print the ones that we are going to use. And I went through those over the past couple of days, finding which ones we needed. But first things first, I wanted to change the column headers here to make it a little bit easier. For one, we have periods in these two or these three column headers. Pandas can't read that. A period separates your variable from, say, a function, and when it's in the column header name, it doesn't understand. It can't read it. So we need to get rid of those periods, and also I'll be switching everything to lowercase. And how we do that is just by hitting your variable T3 dot columns dot str for string, replace. We're going to replace the periods with nothing. We're going to have it do T3.columns again equals. So basically it's saying I want you to save the column names as T3 columns, but replacing any periods with nothing. Now let me show you what that looks like. See, we've gotten rid of the periods here. Now we have this dash, and that's going to pose another problem. I'll show you here. Whenever I do geo and hit tab, all three of those names should come up, but it doesn't. The dash, similar thing to a period, it doesn't understand it. That's not a way to separate a column header. So we are going to copy and paste this code here, and we're going to add the dash and replace it with nothing. So again, there we go. Now as you'll see, geo ID gives us all three. So the next thing that I want to do, and it's just really a house cleaning thing kind of, I don't like to have capital letters in my header columns. I don't want to have to keep on thinking like, okay, it's capital T this or capital G that. It's just easier if I can just type out the names. So very similar thing. We're going to do columns equals t3.columns.str, and this time we're going to call lower. And there we go. Now the other thing I want to show you real quick, it's actually pretty cool how this works. You can do this all in 3 lines of code, but it's a little bit messy. So actually what we're going to do this time is I'm going to copy this string replace here, and I'm going to throw it on the end of this one. And I'm going to go down here and copy the string lower. Now I've already rerun the code to basically to reread in our tables again. So everything we just did is gone now, as you can see there. This time, let me get rid of these two. I'm just going to run this code, which is all 3 of our commands at once. And there you go. It's the same thing. They kind of stack onto one another. You do have to be a little bit careful. There's some things that you can't do. You can make this more complicated, basically, and I won't get into all of that, but sometimes some string functions aren't going to work immediately after another one. So this one is just one that, since it's the same thing over and over followed by just lowercasing, it's easy. So now we have that, but we still have the 560 some columns here, and we don't need them all. And so I believe yesterday I went through and got the columns that I knew we would want by basically looking them up in the metadata in the file. And I went ahead, and this is going to be posted in the description section, these 2 lines of code here. So we've done something similar like this before. We're telling T3 to only print these columns, and I put all I believe it's 14 columns total. The column names inside of the two brackets. Save that as variable t4. And then I'm going to run t4.rename, and in parentheses, columns equals open bracket, and I've renamed the columns accordingly. So hd01 underscore vd02 will be mean rent. Whenever you're renaming columns, you will have the old column name first, a colon, and then the new column name. And then I'm ending it with an in place equals true after the closing curly bracket, separated with a comma, so that it just saves it within the same t4 variable. Boop. Oh, right. I keep on forgetting to change this. What was it? Geo display. Right, I didn't put in that one there. There we go. I put in an underscore in a previous version, and I haven't used it since. I keep on forgetting to change that. So now, let's do t4.info to see what our data looks like. There we are. I should get rid of that one. Okay, so there we are. And see, everything is a non-null value, 5162 rows for each one. Everything's an object. And of course, some of these will remain objects, but most of them are still numbers. So the first thing that we can do to see if it's going to work, just to transfer these over, we know mean rent should be a number. So let's do t4.meanrent.asType, and let's do int. Excuse me. So it can't do it because apparently some of these values are just a dash, and it doesn't understand what that is. So there's a problem with this data set, with this column in particular, and now we need to figure out, okay, so what values are not dashes, or what values are not numerals, and how do we change them? First things first, let's filter out the numeric values, because all we really want to see right now is the dashes. How we're going to do that is similar to what we did before, where we have those double open brackets. Well, this time we're just going to do single brackets, and we're going to, and that's how we do a filter. So I'm going to do t4 open bracket t4 dot mean rent dot str for string, and this is going to be a little bit backwards at first, but what we're going to run is an isNumeric function. And what this is going to do is it's going to filter through only the values, the string values that are only numerals. So now I have an entire data set of only the mean rent with numeric values in them. And I can double check by doing right after this, oh, I'm sorry, I need to do this, dot mean rent dot value counts. Okay, I don't see a single thing there. Let me sort the index at the end. Yeah, everything's fine. So we know we have that. Actually, let me go ahead and change this here. So that looks like it's gotten rid of anything that isn't purely a number value. But we want to know what values aren't numeric. And with a string function, and part of the reason why I wanted to change this over was, with a string function, and this is why I changed everything over to an object in the first place. It's actually easy to run the opposite of what you're trying to filter simply by adding a tilde after the first open bracket but before the variable name. Now we're running the same thing, and now we see it's not just the dashes, but there is one value in here that is 3,500 plus. Now, for an int, an integer to read or a float to read, it cannot have any of those punctuation marks. It reads just the numerals, doesn't separate them by columns or by commas. You can format that later, but for what it's reading right now, it can't read any of this. So we need to now read through that column, replace all of these dashes and commas and plus signs with nothing. And then we need to convert it back into a number so it's usable. So first things first, we want to do mean rent dot str dot replace the dash with nothing, and again str dot replace comma with nothing, then str dot replace plus sign with nothing. And to apply it to the whole column, right before this we do T4 open bracket in quotation marks mean rent close bracket equals that. And now that's going to replace everything in there. Let me go ahead and there we go. But now it's showing us that we still have 109 blank string cells. It doesn't read them as nan values or null values because it still thinks that I guess that there's something there in some respect. And this is where things got tricky. See, with ints, with integers, you can't have a typical nan value. Not in the way that a float can have. With a nan value, that is technically a float value. So if I try to convert this to an integer now, it's not going to read this blank cell as anything, and it's going to give me an error message. So I need to convert the blank cells now to a numpy nan value, and then I can convert it over, but I can't convert it to an int because there are floats now, because there are nan values now. It has to be converted to a float. So here we go. To do that, we're just going to call very similar. Actually, let me just go ahead and copy this over. And we actually only need one of the replacements. And it's not going to be a string function this time. Instead, it's going to look for nothing. And we're going to put in mp.nan. Now, let me copy and paste this back into here. We'll read these. Oh, right. Can't read that now. Let's do it like this. T4 dot mean rent dot is null. There we go. And it is still a float right now. So without changing it as a float, I'm actually going to just run this as type string, and this allows me to apply a string function to it. Contains a comma. Nothing. So we've gotten rid of all of our bad variables here, basically. But we still have 14 other columns to go, and I'm not going to stretch out this video to show you each one individually because it's basically the exact same steps. So I'm just going to copy and paste the code in here and just briefly walk through what it's doing. First things first, I wanted to, let's see here, I'm going to show you how we can print off basically a large chunk of these value counts, and since we've already done mean rent, I'm going to go take that out of here. But basically, I've just put in the same thing for the value counts as we had before, and I had it print, and in parentheses, all the entire variable. And then underneath here, it told me everything that I'm looking to change. As you can see here, there's a dash under median household income, so we got to replace that one. We didn't have any non-numerics in these three columns, so they are going to be fine. And over here we have another dash, capital N, dash, a dash and a comma. This one here, the median income for workers, is an X. We are going to, well, we might actually just go ahead and drop that column now, actually, because there is not a lot to it. All families in poverty. Oh no, I'm sorry, that's median income. All families in poverty is an X, so that's the one that we're going to end up dropping. Then this one's really long. This is actually a percent one, and because it's asking for a value count and there are so many different values, it appears so long, but I believe it's just the dash that we need to get rid of. All people in poverty, same thing. For these census tracts, sometimes the community is so small they can't provide an estimate like that. So we might actually just go ahead and get rid of both of those. But we do have the percentage, and the same thing here. We have a negative sign. So let me copy and paste again here. Basically, everything that we just did, only it's going to be for each one of these columns. So basically, I had to do this in 3 steps. First, you replace the string values that you don't need, and then you replace the blanks that are going to be left over with mp.nam, and then I converted it all to a float, just so that it's an easier workaround than having to just make everything an int. We can make them integers later for the ones that'll fit, but for now, we're just going to run this, and this will give us our table. Okay, mean rent is now afloat. Perfect. So now we have all that. Let's bring up our data table, and now we are pretty much all ready to roll. I am going to drop these 2 columns since their only value is X. They're useless to us. So I showed you how to filter out the columns before, and now's a good time to show you the drop function. So here we have just 2 columns that we want to get rid of. Very simple. You just do the T4, the variable dot drop columns equals open curly bracket, and then quotations, all families in POV, comma, open quotation marks, all people in poverty, then comma, in place equals true, and there we go. Good. So I did just want to show you one thing before we end this here. Just a quick look. Let's say that your immediate question was, what is the highest mean rent out of all this data? To do that, just simple function of sort values by equals, and then in quotations, mean rent, comma, and the default is to put it in ascending order. So it's going to start with the lowest, and then at the bottom will be the highest, but we want the reverse of that. Ascending equals false. There we go. There's that 3,500 rent. I'm going to bet that, yep, that's our highest one. That's the one that was giving us trouble before. So you can see here we're starting out Georgia, Kentucky, South Carolina, And of course, since everything's usually pretty easier to digest in top 10 lists for some reason, we're going to do head 10. And now you just have your top 10 highest mean rents. You can see how many people are over 16 in this, how many people are in the labor force. They have a population unemployed in the labor force of about 20 people. Very low unemployment there. Median income, median household income. Wow. Very low poverty in those top 10 ones. Now that's interesting there. We got one at 16.7. Looks like Hall County, Georgia. So, yeah, I think you can see just how the analysis is starting to shape up here. So we're going to end this video here. Next video I'll go into later on this coming weekend. We're going to start talking a little bit more about analyzing data and how, as a reporter, how to approach the data. I might actually just start that video off without any code and just go over some of those basics. But anyway, thanks very much. If you have any questions, comments, of course, leave them below. Yeah, I'll have all the links to the sources for all this in the description as well. Thanks.